Let's talk about the quick practice. So you already have some interactive slides here that were just a part of the digital learning environments. But here's a video that will help you to know the reasoning behind them and then how to use them with your students. So this slide is slide 4, and it just goes to show you the second grade example of how even in second grade you can see how this is their introduction to, there are 12 dots here. The only thing that's changing is where that break apart stick is. So the 12 is still the total, which you can see on the left. 9 and 3 are the partners. Or we can say 12 is the same as 9 and 3. Notice the 12 is the same, but now we have 3 and 9. So 12 is the same as 3 and 9. So whether you're even looking at subtraction, 12 is the same, 12 is the total, 9 is a partner, 3 is a partner. So we're looking at very similarly this particular quick practice of what is the total and how can I use that to help me know what the partners might be. So I would say, class, read it with me, 9 equals 4 plus E, or with a student leader. Think about it, class, what's E? And they should respond, E equals 5. Now, some students could very much benefit from seeing this with and or alongside of a math mountain. So it could benefit them if you hear students who are not using the correct language or not knowing how to find it. That if you were to draw a math mountain next to each one, you'd say class, and for each one of these they need to tell you if it's the partner or the total. So if students do not know how to get E by itself, you'd say, friends, tell me if it's partner or total. Class, total, partner, partner. So let's put it on a math mountain. This visual might then just help them to see, oh, I get it. What we're looking for, what goes with E to make 9. E equals 5. Next one, class, read it with me. R equals 7 plus 13. Class, think about it. Class, R equals 20. But again, if we're hearing incorrect answers, you might just help by putting the math mountain on this first set of problems until students start to visually do that themselves. Class, partner or total? Total. Partner or total? Partner. Partner. Boys and girls, how would I solve for this? 7 plus 13, so R equals 20. Class, read it with me. 13 equals 18 minus F. Think about it. Class, F equals 5. If they're not sure, quickly, math mountain. Let's point to each one, partner or total. It's a partner. That's always a misunderstanding. This is a partner because it's not the total. When we're subtraction, that number is the partner or the total, the number we're subtracting from. So 18 is a total. That means 13 is a partner and F is a partner. This will help them to see, of course, we could count up to get to 18 or 18 minus 13 to get F by itself. So that's how I'd run it with my students. I just gave you a scaffold there of what you could do to draw next door to it to help students remember what they did do in second grade to get those variables by themselves and what the total and the partners really mean. The next set of quick practices you have, you can see that the same thing happens here, but now we start to do comparing. So you first just do read the equation, find the variable. But now you're going to do comparing. Class, read it with me. 560 compared to 651. Think about it. Class, will we use greater than or less than? Class, less than. And the student leader would take the less than sign and drag it up. Now, if students are forgetting what that says, every time we reread the entire sentence. Class, read it with me. 560 is less than 651. If they don't remember what symbol to put there, then we would say, boys and girls, is 560 less or greater than 651? It's less, so we're going to put 1 dot. This number is greater. Now connect. That tells us we need the less than sign. Then we move the purple tile. Class, read it with me. 5,298 compared to 5,098. Class, is it greater than or less than? Class, greater than. And we can go through the same process. You just want to keep it as choral responding as possible, everyone reading numbers, and then you could turn it into a number talk at the end. Choose one of them and have kids defend why that's true. Why? How do we know that 5,298 is greater than 5,098? We're not going to do it for each one of these, but it's definitely something that we can do to build some more flexibility and reasoning skills. So you'll do comparing, and then you'll do finding the variable as you get through to lessons 4 and 5, and then you can tell that it continues because what you see here is the value of the numbers continues to go up. So we'll continue to compare place values. You could even, for many of these, if they're struggling with knowing which one is greater than or less than, you could choose then to do a proof drawing. So the student leader would draw 5,200, so on. That's a poor drawing, but you get the point. 5,298, 5,098, then you could compare. You could see that they both had 5,000s, but only this one had hundreds and this one didn't have any hundreds. So this number is greater. So feel free to add scaffold as the teacher to each one of these by drawing, or on the variable example with Math Mountain. It might take the student leader too long with that, but if you tag teamed it and you did the drawing and they did the leading, then I think it could work.